Okay, right, here we go, session 24. We're looking at some trig identities here. So last time we looked at solving trig equations. This time we're going to be manipulating them and also doing a little bit of solving as well. Right, let's get straight in. Right, okay, so trig identities, that's just short for trigonometric identities. Right, we know right back from GCSE or even younger that sine theta is equal to opposite over hypotenuse, okay? The opposite over the hypotenuse of a triangle. Let's just quickly draw the triangle out. We've got theta, 90 degrees, opposite hypotenuse. We'll put the adjacent in there as well. Okay, so that's what sine theta is. And we know that cosine theta is A over H. The adjacent over the hypotenuse, and we know that tan theta is O over A, the opposite over the adjacent. So if I was to say to you, okay, what is sine squared theta plus cos squared theta? Okay, let's have a look at what that might be. Now you'll remember from the video before, sine squared theta just means sine theta all squared, and cos squared theta is cos theta all squared. Okay, right, let's put that in. Well, we know that sine theta is O over H, and we know that cos theta is A over H. Okay, let's keep going. So O over H all squared is just O squared over H squared, and the other one, cos squared theta, is going to be A squared over H squared. Well, I can add those fractions together because I've got a common denominator. So I end up with O squared plus A squared all over H squared. Okay, well you might think, okay, well that doesn't help us much. Now let's just think about this triangle. So going right back to the original triangle up there, O, A and H, and using Pythagoras, I know that O squared plus A squared equals H squared, because it's a right angle triangle, yeah? So the two shorter sides squared equals H squared. So therefore I know O squared plus A squared equals H squared. So I end up with a situation where I've got H squared over H squared, which equals 1. Okay, so I know that sine squared theta plus cosine squared theta equals 1, and that is what we call an identity. It's something that's true for all angles, and we can use that in some questions later on. So that is identity number 1. Okay, really important one you need to know. Sine squared plus cos squared equals 1. Now, if I do another one, so also, let's see what happens if I do sine theta over cos theta. So let's just see what that is. The sine theta, remember, is O over H, and cos theta was A over H. Now, this is what I call a sort of a stacked fraction. To make this a little bit easier for myself, I can times the top. As long as I times the top and the bottom by the same, that's fair. So if I times it by H and the bottom by H, well, that just gets O over A. And O over A was tan theta. And that brings us to our second identity. So sine theta over cosine theta equals tan theta. That is identity number 2. And I'll just put the other one next to it. Sine squared theta plus cosine squared theta equals 1. These are the two you need to know. Okay, you need to learn and remember these. So learn these. Okay, so learn those two identities there. Right, let's look at some questions then. So how would these even be worded in a question or exam style question? E.g. 1, solve solve 2 cosine squared theta minus sine theta minus 1 equals 0. Okay, so you could be asked to solve this. Quite a lot of marks involved here. I need to give a range, which is going to be 360 to negative 360, okay? Now the problem here is I've got cosine squared, I've got a sine in there. So step 1 is to try and make every term, so make all terms the same trig ratio. Now trig ratio, I just mean sine, cosine, or tan, okay? So that's the first thing I need to do. I need to try and convert this so they're all in terms of sine, all in terms of cosine, or all in terms of tan. Now to do that, I'm going to use my red boxes. Now the one on the left, the one with tan in, I don't think that's going to help me. But the one on the right will help me because I know that sine squared theta plus cosine squared theta equals 1. If I rearrange that, so we know that, so therefore cosine squared theta is going to be 1 minus sine squared theta, okay? I can now substitute that into my equation. So instead of 2 cosine squared theta, I'm going to replace cosine squared theta is the same as 1 minus sine squared theta. So I'm just going to replace it. Still got minus sine theta minus 1 equals 0. Now I've got them all in terms of sine theta, even though there's a squared. I can now solve this. So let's multiply it out. Okay, let's simplify it a little bit. That becomes plus 1 equals 0. And at this stage I've got a quadratic, a secret quadratic. So if you watch the last video, the tip here is to say something like let y equals sine theta. So I end up with a situation, so I've got 2 minus 2y squared minus y minus 1 equals 0. And I can solve this like a quadratic. Now I don't like that negative 2y squared, so I'm going to make it 2y squared times it all by minus 1 plus y plus 1. That should be a plus there, so that's a minus equals 0, and I can factorise this, I think, 2y all over 2, the two numbers times to negative 2 and add to 1. That's going to be plus 2 minus 1. So you get y plus 1. So, okay, therefore y equals negative 1 or y equals a half. And I know that what y is, y was sine theta. So sine theta equals negative 1 or sine theta equals a half. And I do the same as what I did in the last session. So split this in two. I get the first value from the calculator. So I do inverse sine. And I'll just do that. So shift negative 1. And I get negative. And second value, remember using that tip box, is 180 minus the first value. Just be careful, it's a double negative. It's going to be 270. And then I add or subtract 360 from these values. So if I do negative 90 add 360, well, that gives me the 271. And if I minus 360, that's just going to take me back. So I don't think there's any other. I think for that equation, there's only two answers. Now, if I go on the other side, first value I get from the calculator again. So this time I get 30. Second value, remember I do 180 minus the first value, so 150. I then need to add or subtract 360. So if I minus 360 from 30, minus 330, that's within the range. Remember the range was between, I said it right at the start of the question, it was between 360 and negative 360. And if I do the same on this side, if I minus 360, I get negative 210, so that's going to be in my solutions as well. So I think I've got 6 possible answers here. So theta, could it be minus 90? It could be 270. It could be 30. It could be negative 330. It could be 150. Or it could be negative 210. Okay, let's just pick one, say 150. Let's check right back at my original equation. going to show you a tip for these. Right back in my original, and I'm going to type it in algebra this time. So it's going to be 2 cos, I'm going to call it x instead of theta. So cos x, just be careful. I need to make sure it's that squared. So when you type this in your calculator, cos squared theta should be written like that. Minus sine x minus 1. I can type it in like that. Okay. Now I'm trying to get it equal to 0. So calc, if I press calc and then type in my values, and my first value was minus 90, so negative 90. If I press equals twice, I get 0. So I know that one's right. I can then just check all my answers. So calc, the next one, 270. 0, I know that's right. Let's check the next one. Calc 30, and I can go through every single one. 0, that's good. Calc, and I get 0, and I'll get 0 for the others as well. So I know all of those are correct. Okay, so that's how I would approach that sort of question. Right, the next one is a bit of a proof sort of question. So EG2, and it is show that. Now show that means you've got to show every single step. Tan x so show that tan x cos x over root 1 minus cos squared x equals 1. That's the question. And we're going to use those 2 red boxes again. So let's just refresh our memory on that. So I know that sine theta over cos theta equals tan theta. Remember that was one of our identities. And the other one was sine squared theta plus cos squared theta equals 1. That was my other one. And I'm going to use these, whenever you see a question like this, it's going to involve these trig identities, okay? And it takes a bit of practice. So I know immediately tan x is going to equal sine over cos. So I'm going to just replace my tan with sine x over cos x. That's my tan replaced. I've still got cos x there, okay? And on the bottom, can you see 1 minus cos squared? Well, that's the same as, remember 1 minus cos squared x actually equals sine squared x. That's a rearrangement of this one. So I can say that, well, that's the same as root sine squared x. And on the top, you'll notice that the cos squareds cancel. So I'm just left with sine squared x. And on the bottom, well, the square root of sine squared is just sine itself. And therefore it equals 1 as required. Okay, so those questions there, you just have to work through, and just sometimes you'll have to try different options to get them to work, but just keep persevering and eventually you'll get there. You won't ever need to use anything other than those 2 identities though, okay, or rearrangements of them. Right, okay, that's this session. Well done, thanks for following. Page 176 to 177 today. Exercise 6F, and I want you to do questions 2, 4, and 7. Okay, thanks again. I'll see you in session 25 for the very last session of the course. Well done.